Section 11.5 is looking at the volume of pyramids and cones. And pyramids and cones have a special, basically a property. So I'm going to try to give you a visual of what's going on. If you think about how a pyramid, it's similar to a prism, but it only has one base, and then the sides taper up to a single point. So what happens is the volume of what a pyramid can hold is going to be a third of what the volume of its corresponding prism could hold. And we'll take a look at a visual of that. So basically your volume formula is 1/3 of the area of the base times the height. Now, another option besides multiplying by 1/3 is to divide by 3. So you can take the area of the base, you can say volume equals area of the base times the height, and then what you can do is you can draw a fraction bar under that, and then you can divide it by 3. And some people find that a little bit easier to do than to try to multiply by 1/3. So I'm going to give you that option, and when I show the work and the problems, that's how I do it. Now, the same thing goes for the cone. Okay, so you have one base, it's a circle, so it's similar to a cylinder, but it doesn't hold its shape all the way up to another base. It tapers to a point. So again, we take 1/3 of the area of the base times the height, and the area of a circle being pi r squared means we're going to have pi involved in this. So here we have a little visual that says the cones and the cylinder have the same base and height. It takes 3 cones full of rice to fill the cylinder. So in other words, the cylinder is 3 times bigger than the cones, or the cones are 1/3 as big as the cylinder. This is why we take 1/3. Now, I'm going to show you a visual of this. What we can see here in this visual is that we have a pyramid, and I can adjust the pyramid if I want to change the height. Maybe I'll pull the height up to, let's say, 9.5. Okay, so I've got a height of 9.5, and I have a base that's a square. It's a 10 by 10 square. But what I want to show you is the prism around it. So if you were to build in the prism, what you would find is that the prism, I'm going to go ahead and pull this up, is going to be built around that pyramid, and that prism is going to be 3 times bigger in volume than the pyramid is. Likewise, the same thing happens with a cone. If I wanted to show the cylinder that's surrounding the cone, I can do that. I'm going to go ahead and check this box. So you can see that if I were to fill up that cylinder with water, it would hold a lot more water than just that cone could hold. And so therefore, the volume of the cylinder is 3 times what that cone would be. So the cone is 1/3 of what that cylinder would be.